So we want to explore further how we move from research to reality across industry, academic fields and applications. Our global audience will shortly be able to join their special interest groups or browse the online booth. We encourage you to do so. But how do all these different fields and challenges knit together? Well, we're going to hear now from Martin Aston, who's the Managing Director at Forvanda, and Professor Danielle George, who's President of the Institution of Engineering and Technology. Martin, Danielle, welcome to both of you. Take our discussion on from here.
Super job. Thanks, Declan. Yes, Dan and I are going to have a discussion here to try and introduce the discussions that are going to take place within a number of forums after our brief session. I'm going to start the discussion by talking about the actual reality of the situation that we find ourselves in. We're at a point of inflection in the history of mankind. We find ourselves in a situation where we now understand the impact we're having on the climate of the planet. But we also want to retain the lifestyle that we've come to enjoy. And the only way we're going to achieve that is with significant technological advance. And that isn't just an incremental improvement on what we're doing today. It's a fundamental change to how we do things. In various discussions or presentations we've seen before, we've heard a lot about system of systems. We've heard a lot about simulation. And I think what's important to understand is that isn't how we do engineering today. And we really do need to re-engineer engineering. We're going to have to make use of data, but we're going to have to do it in an innovative way. And so what is currently research needs to become reality, and it needs to become reality very quickly. Dan, I think you would agree with that?
Absolutely, yes. Yeah, I mean, I think from my point of view, I sort of wear two hats with this. I'm an academic in a university where I teach the next generation of engineers, and then as president of the IET, I've also sort of got a hat on to make sure that we look at the standards that are needed in terms of data-centric engineering as well. And like you say, Martin, I mean, data is just the key enabler now, isn't it? That it makes. We need it to make that sort of fundamental change possible while still trying to sort of carry on with our lives as well. So I think it's really essential that data-centric engineering adheres to and evolves standards, and that's the role that the IET can have with making sure we get those standards, and then for this convergence to become the new norm. So our engineers will be data-centric by default, and that's the role I think academia has and the sort of teaching professions have, to make sure that we are graduating data-centric engineers by default.
And I think the other thing that's quite interesting is we talk a lot about data. Part of what we need to do is actually break down those sector boundaries so that data can actually travel directly across those, what should we call, traditional boundaries, if you like. So people talk about the automotive sector, they talk about the energy sector. When you're designing a battery car, surely you should be integrating those two design processes. But the other thing is we've actually got to look at the entire supply chain, and how do we actually integrate data across the supply chain? I mean, there was an interesting presentation earlier about cybersecurity. How do we make sure we don't end up with fortress data? I mean, huge amount of research needed into these areas.
Yeah. It's interesting though, Martin, is it? Because we still need domain specialists, don't we?
Mm-hmm.
And so how much from a education point of view, how much should we teach domain specialism, and how much of it should be that sort of overall systems engineering thinking as well? And I don't think as a higher education sector generally we've got that quite right yet.
And I think it's the entire research and education ecosystem, because what we need to do is to understand how does all the research that's going on into data science actually advance what we're doing in engineering. What's quite interesting is if you look at what's done, and it's interesting, someone from Facebook here, if you look at how Facebook has completely transformed communication between people, it's brought together people. How can we take some of the methodology from Facebook and integrate our industrial supply chains?
Yeah. And I think that does have to start, quite early on in that pipeline. I think we've all got a role to play in that. And, making sure that it's understood. It's not just sort of an add-on. It has to be fundamentally embedded in what we need engineers to do. And that has to start very, very early on and not be something that almost engineers have to learn when they go into industry, like an add-on.
Exactly. I think another point that was raised earlier as well is around the volume of data. I mean, I'm afraid I'm one of those people that believes you should generate the absolute minimum that you need to make an informed decision. But my experience in 40 years in aerospace, which is highly regulated, you have to keep data for a huge amount of time. I mean, for an aircraft program, you keep it for the life of the aircraft program plus 7 years, which means we've got to store this data we're going to generate, these petabytes of data, for possibly 100 years. Now, who is doing research into long-term data curation to guarantee that we will have that data? How do we make sure that the engineer in 80 years' time can actually read it, can actually interpret it? Huge issues.
Huge issues, yeah. I mean, if I can just add another huge issue to it. In my research, I work with radio astronomy telescopes. I design instrumentation, electronics for radio astronomy. And nowadays, they are huge instruments. They're massive science facilities. And the amount of data they're generating is just extraordinary. It's a huge amount of data. One of the projects that I work on, it's generating 17 petabytes of data every single minute. And and what do you do with that? How do you store it? How do you send it around the world as well? And how much of it do you actually keep longer term? Like you say, I mean, hopefully not for 100 years, but how long do you keep it for, and where do you keep it?
Which is why I think it's really important, and it's quite useful. This session is talking about going from research to reality, because the research has to provide us with the wherewithal to address some of these issues. Because if we can't find ways to curate data for decades, then we can't make that transition to data-centric engineering. We'll still have to be a more traditional test-based approach. We won't be able to use numerical simulation to the level that we need to. Yeah. So these aren't nice to haves; they are must-haves.
That's right. Yeah. They're absolutely embedded in what we need to teach and how we need to teach things as well. And to make sure, like you say, we bring that sort of research, the fundamental research, as well as the sort of higher technology readiness levels into a lecture theatre, if you're at university, and make sure that the different sectors are connected as well. So we all have this problem in different ways. We've just given one example each there of two very different sectors, but we share a very common problem of data and what we do with it. So it's making sure that we do sort of smash down some of these barriers that I think we have between different sectors, and make sure that we are all actually helping each other to solve this common problem.
And I also think we should stop using the word problem, because I think this is a massive opportunity. It's, if you look at what we've got to do, we've got to transform the way we use data. We've got to re-engineer the way we do engineering. This should be the most exciting time ever to be in engineering and to be in data science.
Yes. Yeah. You're right. Yeah, right. We shouldn't look at it as a problem, but the habits and minds of engineers, we are creative problem solvers. So we should be able to do it. But you're right, it is an absolutely huge opportunity, and I think it's, like you say, it's something that we literally have to almost start again with. We have to go back to the fundamentals, and I like your term. You have to re-engineer engineering.
And maybe rather than problem solvers, engineers become opportunity realizers or something. I think we've got to stop looking at it as a sort of negative connotation and start looking at this as a huge opportunity.
Yeah. We sometimes look at it as that sort of deficit model, don't we? And it isn't. It's, like you say, a huge opportunity with a lot of very, very interesting challenges to work on.
And we need the people to do it, which is why the education system is so important, because it's not just generating more of the people we've got today, it's a completely new type.
Yeah, absolutely. we've got to have a really good pipeline of these data-centric engineers just absolutely embedded, and also making sure that when we do have it, we have standards. We have our professional institutions working together.